This is the second video for section P5, Rational Expressions. Today we're going to talk about complex fractions. A complex fraction is when you have a fraction and there is a fraction within a fraction. And that's what our expressions are that we have on our note page today. It could also be a decimal within a fraction as well. All we need to know is that those expressions are never considered in simplified form, and we have to find a technique to rewrite them. So there's actually two methods that we can show you for any one of these examples. So that's what we're going to do today. We're going to show you two different methods and let you decide the method that you're more comfortable with so you can apply those methods on your homework. All right. Now the first method I'm going to use here is just to rewrite that fraction. My fraction can be thought of as numerator divided by the denominator. So that's what I'm going to do first. I'm going to rewrite that as the numerator, which is 3 minus 2 over x, divided by the denominator, 5 plus 3 over x squared. All right. Now, before we can actually do this division, which we saw in yesterday's homework, we would usually take the first fraction and change it to multiplying by the reciprocal of the second. But you can't do that unless you have both parts of your division written as a single term. So the next thing that we need to do is to take both of these expressions and rewrite them with a single denominator. So that we had a little bit of practice in yesterday with the adding and the subtracting. So the first fraction, as I look at it, it should have a common denominator of x. This is a 3 over 1. So LCD of x, and the fraction here would be multiplying as x over x. So that's going to be giving me 3x minus 2. And then the second fraction, I'm going to have a common denominator of x squared. So with this being a 1 as it is here, that's top and bottom is going to multiply by x squared. So I will have a 5x squared plus 3 over x squared. Now I have my fraction to the point where I'm ready to change that to a multiplication and flip the other fraction over. I couldn't do that before when my two expressions had two separate fractions. Now we're able to rewrite the problem as the first fraction times the reciprocal of a second. So I can flip that second fraction over, and I'm multiplying by x squared over 5x squared plus 3. And as we move up a little bit, I can see from what we've got here, I've got like factors here that I can reduce. I don't have any like factors here, and they're not going to break down, so I can do some reducing right in here, but I cannot do any reducing here. So as I come down and I write, I will have x squared times 3x minus 2 over the x times 5x squared plus 3. And the reducing can apply right here. I can reduce the x squared over x and leave my answer as x times 3x minus 2 over 5x squared plus 3. And there we have an answer to the first problem. So that method involved making sure that you were aware that you had to get your two fractions as individual fractions, numerator over denominator, before you could flip and multiply. Now we're going to move over to the same example and look at it by another method, which we're referring to as the LCD method. Now the first method that we did should actually help us out here, because back in that problem we actually could compare both parts of that complex fraction and see what the LCD was between both of those denominators. So as we come over here and look at that, the LCD method is going to ask you to look at that and again identify that LCD. Once you can do that, you want to multiply the numerator and the denominator of the complex fraction by that LCD. So here's what it's going to look like. We have 3 minus 2 over x, and that's over the 5 plus 3 over x squared. Now, from the last problem, we did know that the LCD was going to be x squared. So here's where we go with it. We go back to that complex fraction, leave it in the complex fraction form, and we multiply numerator and denominator of that complex fraction by the LCD, which we had seen was x squared. So I'm really multiplying by x squared over x squared, which is 1, so I'm not changing the original problem, but I also can think about that x squared as being an x squared over 1, and x squared 1 over 1. And then as I come through, and I'm going to have to multiply that x squared times each part of the complex fraction. I'm going to have to distribute through because there are two terms here. And when I'm able to rewrite that, the fraction parts should drop out. So here as I multiply the x squared times the 3, I'm just going to get a 3x squared. And as I multiply it here, I'm going to get minus 2x squared over x. Multiplying through here, I have 5x squared. And the second multiplication is going to give me a plus 3x squared over x squared. All right. Now the reducing should take place, and we should be able to see that we will no longer have a complex fraction. Right here we're going to be able to reduce, and right here. So as we come back to write our expression, we're going to have a 3x squared in the numerator. The x squared over the x is going to reduce x to the first, so it's going to be a minus 2x. And in the denominator, these guys are going to reduce, and I'm going to have 5x squared plus 3. And if I compare my answer to the answer I had over here, you can see the only difference is that this answer already has the numerator factored. And we can easily take that and adjust this answer the same way. The x can come out, 3x minus 2 over 5x squared plus 3. And the answers are identical. They are matching. All right, so that gives you two methods to compare. You can see what you think about those. Usually this method with just such a basic denominator as we have here, which is a single term, the LCD method works really nice and quick. The second example that we're going to look at down below here now, that's a little bit more to it, a little bit bigger expression. Some people find they like the first method better with a problem that has a little bit more expressions to it, like this one. All right, so looking back here, we're going to go back to the first method again. We're going to rewrite it as it's the top fraction. 1 plus 1 over x minus 4 is going to divide by 1 minus 1 over x plus 2. And as we saw in the first problem, we have to get these fractions combined into a single fraction before we can rewrite that division problem as a multiplication. All right, so looking at this first fraction, we do know the common denominator is going to be x minus 4. The 1 could multiply by x minus 4 over x minus 4, and then that fraction is going to rewrite with that LCD, and the numerator is going to be the x minus 4, and then we're adding the 1 over here. The other fraction is going to have an LCD of x plus 2, and again this would be multiplying by x plus 2 over x plus 2, and that would give us a numerator of x plus 2, and then we're subtracting the 1. Right? And now we've got our two fractions combined. The first fraction is going to rewrite as x minus 3 over x minus 4 divided by x plus 1 over x plus 2. And now it's time to perform the division. We can go ahead and write the reciprocals of the second fraction, x minus 3, x minus 4 times x plus 2 over x plus 1. And as we saw with what we did yesterday, we don't have any reducing, we don't have any common factors, either up or down or diagonally, so the answer is going to rewrite as the product in the numerator of x minus 3 times x plus 2 over x minus 4 and x plus 1. No reason to go back and multiply out numerators and denominators. Your answers in the book, they're going to be checking them in a factored form. Much easier for you to see whether they're right or wrong. All right, now we're going to move on and take a look at that same problem with the LCD method. Now we can use our first method again to help us see that the common denominator here would have been x minus 4 times x minus 2. So as we come back and we go to write our problem, we're going to multiply top and bottom by that LCD. So here's your fraction, your 1 plus 1 over x minus 4. And that's going to be over 1 minus 1 over x plus 2. Right. Now we need to multiply by the LCD, which in this case is going to be the product of our two denominators here. It's going to be x minus 4 times x plus 2, top and bottom. And then we're going to have to distribute that multiplication in to both parts of our fractions. So it's going to multiply the 1 in the numerator, which is just going to leave us with x minus 4 times x plus 2. And then it's going to multiply this fraction. So it's going to multiply in the numerator. We have a plus in between. X minus 4 times x plus 2. And the denominator of that is the x minus 4. The denominator portion, same thing. This is going to multiply by that first number by the 1, x minus 4 times x plus 2. And as it multiplies the second expression, we've got that subtraction sign in there, so it's going to subtract, and again, this comes to the numerator, the x minus 4 times the x plus 2 over the x plus 2. Now, we've got to step back and take a look at all this that we've written here. What's happening with your LCD method here is that it's going to let you knock these parts out. The LCD that you've used is going to knock out the denominator of this fraction here and the denominator here, so that we're going to be able to have the expressions left here and then combine them with as they simplify. So let's move up, make a little bit more space, and carry through with the rest of the problem. Right here I'm going to multiply these out. In this numerator, it's going to give me x squared minus 2x minus 8. And at this part, those are canceling, and I've got a plus, so I'm going to be adding x plus 2. Right? In the denominator, I'm going to multiply these two out. Okay? Notice that I did not cancel anything out here. See the pluses and the minuses? You cross this out and you're canceling out parts of the expression that are not factors. These have to be multiplied. You could not cancel those out. Back to the multiplying here. We have an x squared minus 2x minus 8. And here these are canceling out, and this negative sign is coming in, and we have a minus x plus 4. Now we're able to combine the like terms in both the numerator and the denominator, and we'll have x squared here. We have a minus 2x and a plus x, so there's a minus x, and then there's the minus 6. And the denominator is going to be x squared minus 3x minus 4. Now we can look at this and see that it's going to rewrite in factored form as x minus 3 and x plus 2 over x minus 4 times x plus 1. And if we come back and make a comparison of our two answers, we can see that they are the same. But as you compare the two problems and you look at the amount of work involved, I think in this case there was a lot less work involved in the method where we rewrote the two and got the common denominators and then inverted multiplying. Here I think with the LCD method, when your expressions are more complex as compared to the first problem, there's a lot more work involved in the distributing and the combining of the like terms, and eventually you have to come back down and finish factoring your problem. Don't feel that you have to pick and choose a particular method. If you come back and compare the amount of work between the two methods that we've looked here, you may think that that was less method when the expression isn't as complicated. The second method that we did here was maybe a little bit more work, certainly not as involved as the one down here. The more complicated the expression, I think the second method gets a little bit trickier, and you may be safer to stick with this one. But practice a little bit. You've got enough problems in the homework to try some of the more basic problems and a little bit more complicated ones like the second one here and see what happens. All right? We're going to move on now. We're going to move on to the back page and see what's left on the back side. Now the problems on this side have some exponent rules that we can imply incorrectly. We know back from section P2 that the negative exponent rule should allow us to move a power down to the denominator and make it positive. However, that exponent rule doesn't apply if you've got addition or subtraction between the terms. So if we were to apply that rule correctly here, we have to leave those negative exponents in the numerator with their expressions. This a to the negative 1 power right here is going to stay in the top with the b, and it can go down, staying within that numerator. We have to keep the subtraction in there. And then the fraction bar, again, keeping the a and the b to the negative power, gets to rewrite down there. Right? Doesn't go directly to the denominator and change those powers of a squared and b squared that are already down there. They're going to stay down there as a squared plus b squared. So if you know how to rewrite this problem correctly, then you can come back and you can use either method that we talked about on the front side to simplify it. Right? I'm going to go ahead and finish this one up by the first method since we've got it on the left side. So I'm looking at it in terms of rewriting it as a division problem. The top part of the fraction, minus a over b, is going to divide by the bottom part of the fraction, which is a squared plus b squared. Now, I can also think of that as being over 1. Now I'm going to get my common denominators in my first part of the fraction here. Common denominator is going to be a times b, and that means this part of my fraction had to multiply top and bottom by b, so I'll have a b squared. And this part of my fraction had to multiply top and bottom by a, so I would have an a squared. Right? And now I've got that fraction as a single fraction. If I want, I can come back here and I can rewrite my division as a multiplication, and I can flip over my second fraction. 1 over a squared plus b squared. And as I come back to write my answer, I could factor the top. I could factor it as b minus a times b plus a. My denominator is going to be ab times a squared plus b squared. The only thing is, my sum of squares doesn't factor down anymore. So even though I've broken down the numerator and factored it, I don't have anything left that I can do in terms of simplifying this one, and that's done. So if you're curious enough to see what would happen if we tried the LCD method with it, you still have to rewrite the problem in the right form. So I would still have to take this and keep it as b over a minus a over b, and put that entire quantity over the a squared plus b squared. And I like to make sure that we just realize that that's a fraction down there too, and it's over 1. Now I can come back and think about that LCD method. I really don't have a denominator down here to have to worry about LCDs, so I'm just worrying about an LCD based on here. So my LCD is a times b, and I can multiply both top and bottom of that fraction by that LCD. A times b over the top, and multiplying a times b over the bottom. And if you like, you can still put each of those over 1. You're not changing your fraction, you're really multiplying by 1, and as you bring this product and you multiply through, it's going to take care of your denominators. Down here, I'm going to multiply through, but I'm just going to leave it in a factored form. So here I'm going to put this down here, and as I said, in the denominator here, I'm just going to leave it as AB times A squared plus B squared. As I multiply through the numerator, this is going to give me B times AB, which is going to give me AB squared over A. And here I'm going to get subtracting A squared B over B. So here's the reducing. I'm able to reduce here with the A's. I'm able to reduce here with the B's. Move it up a little bit. We can compare our answers. So as I come back to write my answer, I've still left the AB times the A squared plus B squared. And these are reducing here. I get back the B squared minus the A squared. And of course, as you've seen in our previous problem, that numerator does factor. So whichever method you do decide to use, you should, hopefully, be able to get the correct answer. If you find yourself making mistakes with one method, maybe switch over and try the other one for a particular problem. There's no reason you can't use both methods as a combination as you approach the problems in your day 8, which will be your homework that you'll be working on tomorrow. That's it.